All right, so guys, we're going to go ahead and get started here, finally. Section 10.2, Introduction to Conics. We're going to be talking about parabolas today, but I think the first thing that needs to happen, again, is we are in Chapter 10 here talking about conic sections. We need to start to understand really what conic sections are about. We've already studied circles, which are conics. In previous classes, excuse me, or in previous chapters, like back in semester 1, in chapter 2 and chapter 3, we talked about parabolas quite a bit. So we're coming to the table, so to speak, with some information or some knowledge about conic sections. We still don't know what that means. We still don't know what that's all about. So that's going to be the first thing that we need to address today: is what is a conic section, and really what are the different types. And then we're going to take a deeper dive into parabolas. So the good news is that I can't imagine that any of us are freaked out or worried when you hear the word parabola, because we know a lot about them. But we're going to look at parabolas not so much as, and I don't want to. This is I don't know, not the exact way that I want to say this. I just can't think of another precise way. But instead of looking at it as we did with quadratics, we're going to look at it as a conic section. So we're going to, again, obviously we're going to have a lot of similarities because it's still the same thing. It's still a parabola, okay? But how does that fit more closely aligned with what we're trying to go for with conic sections, all right? So the goals that we have in mind, again, this is a 2-day section, but it's the type to where we're broken into, here's the day 1 assignment, here's the day 2 assignment sort of thing. So goal number 1, students to be able to recognize a conic section as the intersection of a plane and what we call a double-napped cone. Already starting to sound weird, but again, we'll have to see some diagrams here in a minute. Second goal, students to be able to find the vertex, focus, and directrix of a parabola. That's going to be our main focus today. Tomorrow, we're going to get into goal number 3 a little bit more, and we say that students will be able to write the equations of parabolas in standard form. So really, we try to break this into 2 different types of problems. So the first type, again, what we're going to be focusing on today is you're given the equation. Lots of times you're given the wrong form of the equation. So we're going to have to get the equation the way we want it. But once we have the equation, then we can identify the parts. Okay, tomorrow it's going to be more like you're given the parts, build the equation. Day 2s generally feel a lot easier than the day 1s. Okay, because day 1 we have to learn about what it is we're talking about. Day 2 it's just piece it all together. All right, so conic sections. Like I said, it's kind of an abstract concept a little bit, I suppose. What a double-napped cone is about. Again, we have to think about this or look at this 3-dimensionally. I do have a video, but it sucks, so we're not going to do the video. It's like the most monotone. I think it's like I'm assuming it was in a different language at some point, so they went through like a computer automated voice. It is. We're going to skip it, okay? I think the only reason I liked the video somewhat was because you could kind of visualize this, and it looked more 3-dimensional than what you see up there. But I think we're going to be okay here. So a conic section, we say it's the intersection of a plane and a double-napped cone. So what a double-napped cone means, what that is. We have to think of it like, okay, first off, we all remember what a cone is from geometry, okay? Clear back in the days, okay? So imagine that you have a cone, and you took the second cone and you put it on top of it, right? So we have a cone on top of a cone, okay? They're sharing a common vertex, right? That vertex point. So one is sitting on top of the other. Now what we're claiming with these conic sections, conic like from the word cone, right? So these conic sections is that if we start to intersect with planes, we could create different shapes, okay? So if I were to draw a plane or have a plane that goes through that is parallel to my bases, isn't it just going to create a circle? That's all that's going to happen, right? Okay, so that's what we've already talked about. Circle's a conic section, great. And what we're going to talk about today is what if I were to have a plane go through, and it goes through the base? Well, that's going to create a parabola. That's what we're going to create on that outer edge, okay? Now, eventually, like next week, we're going to talk about what happens if we have a plane that goes through that's not parallel, but it also doesn't go through the base. That's when we create this oblong, this ovalish type shape that we call an ellipse, okay? And then also, what if we have a plane that goes through both of the bases? Essentially, we call this a hyperbola, or an overly simplistic way to talk through this. It's kind of like we have parabolas that face in opposite directions. Okay, there's a lot more to the story. Please don't think of them as being parabolas that face opposite directions, but that's kind of the initial look. And if that's what we're thinking about in terms of hyperbolas today, because that's not our focus today. Again, but today that's okay, I would say. All right. General ideas, like I said, obviously we're going to talk about each of these in much greater depth. But do we feel like we have? Okay, now I know what a conic section is or where it comes from. Starts with this concept or this idea of a double napped cone. Now, is that a figure or a solid that you see regularly out in the real world? No, it is not. Okay, it's not. About the closest, again, I've tried to think about, okay, what could we relate this to, an object that we see? The closest I can come up with would be like an hourglass or something like that. But even then, it's not a perfect cone over a perfect cone. But again, that's got the general shape. And again, I'm sure that there are other more specific, but I'm talking about like common things that you see on a daily basis. Nothing's really coming to mind. Okay? Any other questions, though, about conic sections? All right, so like I said, now it's just the deep dive into each of these specific types of conic sections. I don't know if this provides a little bit more of a visual, a little bit better visual. Like I said, the circle is going to be the plane that's parallel to the base. The ellipse is going to not be parallel to the base. The parabola goes through the base, and the hyperbola goes through both of the bases. All right. So far, we're, like I said, because this is brand new stuff. You've never talked about this before. Vincent. Yes, but not three-dimensionally. Yeah. I mean, like, you'll have to draw, like, you had to draw circles, right? But it was two-dimensionally in a coordinate plane. You'll have to draw parabolas two-dimensionally in a coordinate plane, but not draw this thing on a double napped cone.
Is there an extra credit
If we do what?
Is there extra credit if we take and make a 3D? You just like 3D print.
You just want to 3D print some stuff? Actually, that would be if you can 3D print one of a double napped cone, that would be helpful to me. I don't know if that's easy to do or not. Like I said, because I do not have anything like physically that I could show people. If you have the capability of doing that, that'd be great. That'd be great. True. And then I was going to say, and then I can, your name will live on in future years. I'll say, I had a student named William, and then I'll probably tell like 15 embarrassing stories about William. I'll say, yep, he made this, guys. If you know William, go make fun of him. He works that fairway. Yeah, that's what we'll do. I'll probably find your picture and put that up there. Don't have your social security number, but yeah. I was going to say I need a little bit more information. I'll have you fill out a couple of those random questionnaires. Yeah. All right, so guys, here we go though. Parabolas. Like I said before, the good news is you know what a parabola is. You've studied these in I would say great detail. We've walked all the way through parabolas, what they're all about, what they entail, all of that good stuff. But we always looked at parabolas in terms of this is a quadratic function, and here's what we can do with it. And I'm not saying that we're totally venturing away from that. That's not what we're doing. But now we're looking at this through the lens of, all right, this is, okay, yeah, it's a conic section. Okay, so again, we are going to be, hitting on different aspects of this, but it's still at the end of the day a parabola. Okay, we still, hopefully we take comfort in the fact that push comes to shove or something sounds weird or looks weird, I know how to build a parabola. I know what we're looking for. It's just, like I said, we have a few other parts here that we're going to care about. So, a parabola is going to be the set of all points x, y in a plane that are equidistant from a fixed line that we call the directrix and a fixed point that we call the focus that is not on a line. So right there, even from the start, this is a different way of defining what a parabola is. Again, parabolas were introduced in geometry. Then you really use them in Algebra 2, and we've really used them in pre-calculus, but it's never been defined this way. And you've never needed to understand really how to build a parabola. It was just always, you put a 3 in for x and you square it, you get a 9 out for y, and that's how the parabola works. And that's true. And I'm not saying that there's anything wrong with that, because now that it's a conic section, we really need to see where this comes from. So again, what we're claiming is that if we have a point, we call it the focus, and we have a line that we be called the directrix. So again, the setup here begins that we have a point that is not on the line. Okay? Didn't we study that a little bit yesterday? Didn't we figure out the distance from a point that's not on the line? Yeah, so again, hopefully you're seeing how some of this stuff is connected. Okay, so what we're claiming is that a parabola is merely going to be all of the points that are the same distance away from the focus as they are from the directrix. So here's the easiest point to find. We call it the vertex. Do you agree that the vertex appears to be the same distance from the focus as it is from that directrix? Yeah, well, so is this point here. That distance to the focus is the same as that distance to the directrix. Okay, I don't know if my sketch is very accurate, but in theory, that's the way it's supposed to work out. Okay? So sometimes it's easier to actually do this from scratch. So what we're saying is that we have a point that we call the focus. It's not on the line, then we call the directrix. So what we're saying is that if we start to build a collection of points that are going to be the same distance from the line as they are from the point, there's the first, okay, maybe we've got another one that's the same distance away, maybe we have another one that's the same distance, maybe we have one over here, all the way up there, that's the same distance away here and here, and pretty soon we're going to realize that we're creating a parabola. That's what that means. Again, is that every point that is on a parabola, and there's an infinite amount of them, every single point is going to be equidistant to the focus as it is to the directrix. Okay, so how many people have heard the phrase or the term focal point? Okay, this is what they're talking about. Like that is the focal point. We call it the focus, right? Okay, so with that in mind, that's structurally where this comes from. We say that the vertex is going to be the midpoint between the focus and the directrix. And let's not overcomplicate that. We're saying that this vertex is the same distance to the focus as it is to the directrix. Therefore, it's the midpoint between the two. Okay. We also say that the axis of the parabola is going to be the line that passes through the focus and the directrix. So if we were to draw this line that goes through the focus and through the directrix, that's what we call the axis of the parabola. I'm going to be honest with you, we're not going to refer to that too often. That's one of our, I would say, low priority. But a textbook is going to say now, if your axis of the parabola is vertical, then you have a vertical parabola. If the axis of your parabola is horizontal, then you have a horizontal parabola. Which is true, but I think we already know how to determine whether or not we have a vertical or a horizontal parabola. Which way is it opening is generally the way that we look at it. It opens up or down, it's vertical, opens left or right, then it's horizontal. Okay? Also, we're going to be focusing algebraically on which term is squared. X squared, it's vertical. Y is squared, that's going to lead to horizontal. All right? So, guys, this next slide, this is one that we're going to want to know where this is at. Again, if you want to highlight some stuff or put a big giant star next to this one, again, these are all your formulas. Okay? Now, going back, 8 years or so, the first year that I taught pre-calculus, I'll go ahead and call it a mistake. Again, I made the mistake of saying, all right, we're going to learn about conic sections the same way that I learned about conic sections. And maybe that was okay to do back when I was in high school, but it didn't go well that first year that I tried to just have everybody memorize a whole bunch of formulas, and frankly, students did okay. Again, we were fine, but there was no continuity. It was like, I know how to find the directrix, but I don't know how that really ties into everything else. Or I know how to find the focus. My focus in a vertical parabola, it's going to be h comma k plus b. And they had all these little formulas and facts memorized, but they had no idea how it all fit together. Okay, so instead, yes, we have these formulas, kind of for convenience, but we're going to worry about this in terms of how does it all piece together? How does it all fit together? And generally, that goes much, much better. Okay? So, first glance here, as we can see, we're working in columns. We have all the vertical on the left and the horizontal stuff on the right. When we're looking at the two equations, the standard form of the equation, what's the difference between the vertical and the horizontal? They are very closely related, but what's the difference? What do we see? Vincent. Yeah, and I'm actually going to go a little bit further than that. Vincent said the x and y are swapped, which is totally true, but it's actually the entire binomial. The x minus h is swapped with the y minus k. Okay, so I guess what I'm saying is that the h is going with the x when it goes, or the k is going with the y when it goes to. Okay, but that is absolutely the case. Remember that if your x term is being squared, that's when it's vertical. If your y term is being squared, that's when it's horizontal.